do his pet snake, and the mouse fought back.
Oh.
Forever. Triumph. Mammals.
Wait, so
Higher
the mouse,
species over reptiles, and
the mouse killed
the mouse mortally wounded the $75 snake.
Okay, you are supposed to have that.
How did it do that?
I wasn't actually there. This came up in conversation about half an hour ago. What's that? Start telling jokes now.
24 minutes.
Okay.
Challenge
Okay,
accepted.
no,
Thanks
we
so
got
much.
serious
Yeah.
questions. Go ahead.
Okay.
All right. So, right now, a day in the life is mini prepping then.
Yeah. Pretty cool, huh? Mini preps.
Yeah, you have the right thing.
Mini preps, which means, yeah, again, taking a plasmid, a small circular loop of DNA out of a bacterium, and getting rid of everything that isn't plasmid. Yeah, so I'm the mini prep guy. Was that actually on your list of questions?
It was.
How does it feel to be the mini prep guy?
It was, can you describe a day in the life?
Oh, a day in the life. Yeah, get here at 10:15. Start doing mini preps. Raid the catered food sometime around lunch. Come back down. Do a few more mini preps. Also, because I am a teacher, try to think of ways in which I'm going to take this knowledge that I'm gaining and foist it onto students. Against their will.
And how will you do that? I mean, have there been?
Oh, I mean, an IGEM. This is so. Have you? Has someone else talked to the camera about IGEM?
I think you should describe it.
Yeah. Okay, so IGEM is the International Genetically Engineered Machines IGEM competition, which is an event, an Olympic event sponsored by MIT. And so schools from all over the nation and all over the world, hence international, gather together in laboratory rooms such as this one to try to make a genetically modified critter, usually a bacterium, that is either A, amusing and novel, or B, useful, or possibly both. And then all these different biologically modified critters are taken to MIT in November, and it's kind of like an engineering, right? This is biological engineering, and so for decades now there have been engineering competitions where student engineers will design robots and have the robots fight on a wrestling mat in the gym or something. And so we can't exactly do that with bacteria. It would be boring. So there are other things, you know, you certainly show the bacteria, but you'll also hype the bacteria with a presentation that you give. You hype the various parts, each of which may or may not be useful, and so on. So, say what? Oh yeah, flash animations that demonstrate exactly what you're doing with your genetically engineered creature that you've made. And ours is, as I'm sure you guys know, getting a bacterium to hear Beethoven's Ninth Symphony and then commit suicide in such a way as to gently release the DNA inside in hopes that that DNA can recombine with other pieces of DNA, which would certainly be fun to have bacteria kill themselves when they hear Beethoven, and useful when they recombine DNA in novel sort of ways. And so, oh yeah, so the question was, How am I going to bring this back to my students? Have them do a little competition in the class. We can get 20 different pieces, say, okay, glue the pieces together and create something, right? So hopefully, if I have a nice, good list of pieces of DNA for them to use, then that will be feasible, hopefully. And because I'm a community college teacher, I can teach a whole darn course about synthetic biology, where students will do the IGEM kind of stuff, and they will also learn about other IGEM presentations of years past, and also the actual useful stuff that isn't just to impress judges at educational competitions. There's the Kiesling lab down the street that I'm sure you're aware has is making progress towards biofuels through the synthetic biology process, stuff like that.
So I guess this is a good spot for you to say, like, what is your name?
Oh, yes.
And how are you involved with IGEM and synthetic biology?
Yeah, so my name is Dirk Vandepol. I am a City College of San Francisco biology instructor. I teach biology there. Right, and what am I doing here? Yes, I've been a big fan of synthetic biology for a couple of years. I think synthetic biology is cool, and so I saw an ISME, which is a Bay Area-wide internship for teachers program that allows teachers, usually high school, also elementary, and so on, teachers, not necessarily of science, to do internships in places of higher learning such as this, also in private companies like National Semiconductor and Intel and all these other Silicon Valley companies. And second grade teachers can go in there and learn about and do actual work and make a contribution to a company like National Semiconductor, and then once they're done, they take whatever they've learned at National Semiconductor and this is not a plug for them. I don't even know where they are, what they do, except make semiconductors, I guess. But bring it back to their classroom, and or they could bring it to their school and say, okay, set up a network for the school or something like that. So I'm not a elementary or high school teacher, but I'm a community college teacher, so I don't know if that was a bending of the rules for them, but I don't care, because I got my cool position doing synthetic biology.
So what is synthetic biology?
What is synthetic biology, you ask? Well, so I guess synthetic biology is, well, I can give you my best understanding of synthetic biology, and that is, it is the full fruition of biological engineering such that I think it taps into the notion of open source. The idea of turning DNA into Lego pieces makes the Lego pieces easier to use, not just for PhD Berkeley professors, but also for undergraduate Berkeley students, biology teachers at City College, anyone who's got a biology 1A background from a general college biology class should soon be able to manipulate DNA as they please and hopefully create something useful. And